Hello students, in this video I am going to discuss about the concept of thin layer chromatography, which is a topic from Unit 3 of Instrumental Methods of Analysis of B Pharmacy 7th semester program. The contents include introduction, principle, methodology, RF values, advantages, disadvantages and applications of thin layer chromatography. A brief introduction about thin layer chromatography. The use of thin layer was first reported in 1938 by two Russian scientists, Izmailov and Schreiber. They separated plant extracts on a slurred adsorption medium which is spread to a 2 mm thick layer by spotting an alcoholic plant extract in the center of the layer and observing the spots as the solution spread. This TLC is a type of planar chromatography in which flat thin layer of adsorbent is used as stationary phase, and the principle is based on adsorption. So a solid stationary phase and a liquid mobile phase is used in TLC. A finely divided solid is spread as a thin layer on a rigid supporting plate, and a liquid mobile phase is allowed to travel across the surface of the plate after loading the sample. The separation depends on the relative affinity of the solute towards stationary and mobile phases. The solute with higher affinity for stationary phase travels slowly, while the one having lower affinity towards the stationary phase travels fast. So this picture depicts the chromatogram of a mixture which is separated into three components A, B and C. So in this, component A is having greater affinity towards the adsorbent layer or the TLC layer. So that is the reason it traveled slowly. On the other hand, component C is having least affinity towards the stationary phase. Hence, it traveled faster and it is eluted at much higher distance from the baseline. On the other hand, component B is having intermediate affinity towards the stationary phase. Hence, it occupied a distance which is intermediate to that of component A and component C. Thus, the individual components are visualized as spots at different distances on the TLC plate. The components are finally identified by suitable detection techniques. So the methodology involved in TLC includes TLC plates, stationary phase, preparation of TLC plates, activation of TLC plates, purification of silica gel G layers, sample preparation and sample application, developing tanker and mobile phase or the solvent, development techniques, detection methods, and finally evaluation of chromatogram. So let me discuss one after the other. The first aspect is TLC plates. The adsorbents are supported over a base which is made up of glass, aluminum or synthetic polymers like polyethylene terephthalate can be used, or even plastic strips can also be used. And the most preferred sizes of the TLC plates include 5 by 20, 10 by 20 or 20 by 20 centimeter dimensions. And the ideal thickness of the TLC plates can lie between 2 to 4 millimeters. Each of these materials, glass and plastic, are having their own advantages and disadvantages. Glass plates can be easily cleaned and they are reusable, but there will be handling problem with glass material. On the other hand, plastic offers greater flexibility. The second stage is selection of stationary phase. Adsorbents should be selected based on the chemical nature of the mixture to be separated. If the mixture to be separated is acidic or neutral in nature, then silica gel G can be selected as adsorbent. In that case, the principle of separation will be either adsorption or based on partition. In case of basic and neutral substances, alumina can be selected as adsorbent. In this case also, the principle of separation can be either adsorption or partition. In case of strongly hydrophilic substances, Kieselguhr can be selected as adsorbent, where the principle of separation is based on partition. For water-soluble substances, cellulose powder can be used as adsorbent. The cellulose powder consists of neutral OH functional groups which have the ability to make hydrogen bonding. In this case, the principle of separation is based on partition. So this is how, based on the nature of the solute, we have to select the adsorbent. Binders are also used along with the adsorbent in order to adhere the adsorbent onto the supporting plate. Binders such as gypsum, starch and carboxymethylcellulose are having wider applications. These binders also prevent the flaking of the adsorbent during development. Commercially available adsorbents contains binders in them. For example, silica gel G is commercially available. Here G denotes gypsum. An inert fluorescent indicator is also added along with the adsorbent. So the TLC plates which are developed by using binder and fluorescent indicator along with the adsorbents, after development of the chromatogram, when we keep these TLC plates in the UV chamber, then the entire background will be appeared as fluorescent background. In that case, the non-fluorescent analyte can be easily visualized as bright spot. The next step is preparation of TLC plates. The slurry of adsorbent is made with water and applied as thin film over the base plate. Film should be thin, uniform and consistent throughout the separation process. Commercial applicators are also available for coating of the adsorbent. TLC plates can be manually prepared by any of the following methods: pouring, dipping, spraying and spreading. These are the 4 methods by using which we can prepare TLC plates manually. Alternatively, pre-coated TLC plates are also available. The first method is known as pouring method. In this method, the slurry is poured over one side of the plate. Leveled surface is maintained in order to allow the travel of slurry from top to down. Once the edge is reached, then the plate is tipped back and forth. In this way, the TLC plate will be completely coated with the slurry material. But the disadvantage with this method is uniform thickness of the layer may not be achieved. The second method is known as dipping method. In this method, 2 plates supported back to back, they are dipped into the beaker containing adsorbent slurry. Then the plates are separated after removing from the slurry. The disadvantage in this method is it requires large amounts of the slurry even for coating the last slide. The third method is known as spraying method. In this, a sprayer is used to spray slurry onto the TLC plate. This method is also having disadvantage that uniform thickness of the layer may not be achieved. The fourth and the best method is known as spreading method, and it is most widely used method. In this, TLC spreaders or applicators are used which are commercially available. So first, the glass TLC plates will be fitted on a base plate. Then the thickness of the layer can be adjusted by using this knob. Then the slurry is loaded into the applicator. So this spreader is rolled over the plate from one side to the other side in this particular direction. And then the layer is allowed to dry. In this way, the TLC plates can be prepared by using spreading method. Alternatively, pre-coated TLC plates are also available. They are ready to use aluminum or plastic bagged TLC plates. They contains approximately 0.1 to 0.2 millimeters thickness. These pre-coated plates are reusable, but they are costly. But Because they are reusable, they avoid the purchase of costly coating equipment. The next step is activation of the adsorbent. After application of the adsorbent, the plates should be dried. Removal of the solvent from adsorbent requires high temperature. So, after preparing the TLC plates, they should be air dried for 30 minutes and then they can be dried in an oven at 110 degrees centigrade for 30 minutes. Further, in order to get the active layers of silica gel or alumina, the plates can be heated in an oven at 150 degrees for 4 hours. So this is how TLC plates will be activated. And then they should be subjected for the purification. It is because silica gel G contains iron as impurity, which causes distortion in the chromatogram. So it is important to purify and make the adsorbent free from the iron impurity. To do so, the prepared TLC plates and the dried TLC plates are primarily developed with a mobile phase containing methanol and concentrated hydrochloric acid in 9:1 ratio. Then they will be subjected for drying. By doing so, the iron impurity present in the adsorbent layer will migrate to the upper edge of the plate along with the solvent front. In that way, that will not cause any distortion in the chromatogram. The next step involved is sample preparation and sample application. Sample is weighed and dissolved in minimum amount of mobile phase. Selection of appropriate solvent for sample is very important. Always dilute solutions are preferred for TLC. Sample can be applied in many ways. So capillary tubes can be used for applying sample. So in this case, if we have to apply different sample solutions, for the application of each sample solution, a fresh capillary tube should be used. Alternatively, sample solutions can be applied with the help of micropipettes or micrometer syringes. The following points should be considered during sample application. Making baseline is one of the mandatory aspects while developing chromatograms in either TLC or in paper chromatography. Baseline should be constructed in such a way that it should be 2 centimeters away from the edge in order to prevent the submerge of the sample in the mobile phase. Loading of small volume of sample is preferred and all samples should be loaded in equal distances. Loading of sample for multiple times with intermediate drying is preferred, particularly for dilute solutions. Okay, you can pause the video for a few minutes and revise the concepts so far whatever you learned and quickly try to answer these questions. Okay, so I hope you have completed answering these questions. So let us move forward. The next step involved is developing tanker and mobile phase. This developing tanker is also known as TLC chamber or developing chamber. These developing chambers of suitable dimensions are used to hold TLC plates for chromatographic development. So the selection of TLC chamber is depending on the complexity of the mixture to be separated. If the mixture to be separated is very simple, then we can use smaller size TLC chambers. On the other hand, if the mixture to be separated is a complex mixture, then we can use bigger chambers. The bottom of the chamber should be filled with mobile phase. 3 sides of the chamber are lined with filter paper which is impregnated with mobile phase and the top should be covered with a lid. This allows for the saturation of the chamber and thus it prevents edge effect. Improper edges of the solvent front due to improper saturation of the TLC chamber is known as edge effect. Proper saturation of chamber with mobile phase ensures uniform and smooth flow of the mobile phase over the plate during development. TLC plates should be always kept at 45 degrees angle in the TLC chambers. The choice of mobile phase, it depends on the nature of the analyte to be separated. If the analyte to be separated is very simple, then single solvents can be used. On the other hand, if the separation is meant for complex mixtures, then combination of solvents are preferred. Further, the selection of mobile phase can be done based on their elution power. For this, please refer Eluotropic series, which I have discussed in column chromatography. The link for the same is given in the description. In case the nature of analyte is unknown, then solvent system is selected based on trial and error method by using small TLC plates. On the other hand, if the nature of the solute is known, then selection of solvent is based on Stall's triangle. This triangle relates the adsorbent activity, nature of the solvent, and nature of the solute. Let us see what is this Stall's triangle. So, as the name itself indicates, triangle consists of three corners. The first corner of the triangle represents mixture to be separated. The mixture to be separated can be a hydrophilic mixture or it can be a lipophilic mixture. The second corner of the triangle represents the stationary phase. It will represent about the adsorbent activity. The adsorbent activity can be inactive or it can be active. While the third corner of the triangle, it represents the eluent. Eluent is nothing but the mobile phase. The mobile phase nature can be polar or it can be non-polar. So when we rotate the M corner of the triangle, depending on the nature of the mixture to be separated, then check the S and E corners, corresponding activity of the adsorbent and optimum polarity of the eluent. For example, if the mixture to be separated is hydrophilic in nature, then keep the triangle in such a way that the M corner of the triangle is oriented towards hydrophilic side. Then the S corner of the triangle will be oriented towards inactive. In that case, we have to use an inactive adsorbent such as Kieselguhr or cellulose as the stationary phase. In this case, the E corner of the triangle will be pointed off towards polar. That means we have to use polar mobile phase. On the other hand, if the mixture to be separated is lipophilic, okay, then the S corner will point out the active side of the adsorbent activity. That means in that case, we have to use active adsorbents like silica gel or alumina. In this case, the E corner will point out towards the non-polar mobile phase. That means we have to use a non-polar mobile phase. Then the next step involved is elution or development techniques. The TLC plates are spotted with the sample solution. And after spotting the sample solution, they should be kept in a pre-saturated chamber containing suitable mobile phase. Then the solute with lower affinity for stationary phase travels fast and vice versa, as I discussed under principle. The movement of components will be seen in upward direction. The individual components are visualized as spots at different distances on the plate. And finally, the components are separated and they are identified by suitable detection techniques. So after development of the chromatogram, they should be air dried in order to visualize the spots. Visualization can be done by using specific and non-specific methods. In specific visualization methods, specific spraying reagents are used in which the functional groups of the solute reacts with the reagent. For example, for this identification of amino acids, we can use ninhydrin solution as the reagent. For the identification of alkaloids, Dragendorf reagent can be used. And similarly, for the identification of carbonyls, we can use 2,4-DNP as the reagent. So in all these examples, whatever the product that we get finally is a colored product. So we can observe different colored spots in the visible light. On the other hand, if we want to identify alcohols, then we can use benzoic acid as the reagent. The finally obtained benzoate esters of alcohols, they show UV absorption. So we can observe them as spots under UV radiation. Similarly, amino acids alternative to the ninhydrin solution, in order to identify them, we can use phthalaldehyde as the reagent. The finally obtained phthalaldehyde derivative is a fluorescent substance. And there are some non-specific visualization methods are there. UV chamber method is one such method. In this method, after development of the chromatogram, when the chromatogram is kept under UV radiation, then the compounds which absorbs UV radiation can be visualized at 254 nanometer. On the other hand, the fluorescent material can be appeared as bright spots against dark background by measuring at 365 nanometers. This method is a non-destructive method. The next non-specific visualization method is iodine chamber method. In this method, first iodine chamber has to be prepared and the chromatogram is kept in the iodine chamber. Analytes take iodine vapors and they appear as brown spots. And they will be disappeared once we remove the TLC plate from the chamber. And this iodine chamber method is also a non-destructive method. The third non-specific visualization method is known as charring method, where sulfuric acid spraying reagent will be used. And it is most widely used technique for the identification of carbon compounds. So in this, a mixture containing sulfuric acid and methanol in 1:1 ratio should be prepared, and that is sprayed on the TLC plates. And then the TLC plates are dried in an oven at 110 degrees centigrade for 10 to 30 minutes. Analytes are destroyed by the acid and they will be absorbed as dark deposits of carbon. The disadvantage of this method is it is a destructive method. Samples cannot be recovered by this method. And the next stage is evaluation of the chromatogram. After development and drying and visualization of the chromatogram, they should be evaluated by qualitative and quantitative means. Qualitatively, the developed chromatograms can be evaluated by measuring the RF values. RF is nothing but retardation factor, which is the ratio of distance travelled by the solute to the distance travelled by the solvent friend. In this example, a mixture was separated into two components, blue colored product and red colored product. Blue colored product has travelled to a distance of 0.4 units, while the red colored product travelled to a distance of 0.8 units. And the solvent friend, the distance travelled by the solvent friend is 1 unit. So in this case, the RF values of the blue colored product would be 0.4 divided by 1. So that gives us 0.4 as the RF value for the blue colored product. While for the red colored product, the RF value will be 0.8 divided by 1. So we will get 0.8 as the RF values. So in this way, the RF values can be calculated for the individual spots. After calculating the RF values, they can be compared with the standard samples under identical conditions. Evaluation of chromatogram can also be done by quantitative methods, like by using direct techniques and indirect techniques. In the direct techniques, the density of the spots is measured by using densitometer. From this, optical density values will be obtained and they will be further converted into the amount of the analyte. The TLC plates are neither destroyed nor eluted with the solvent in this particular direct technique method. And the second method is known as indirect technique. In this method, spots are cut into portions and reacted with suitable solvents. The resulting sample solutions are analyzed by suitable methods. Advantages of TLC. The equipment is very simple to construct. If the separation process is meant for small scale, that can be done even in a simple beaker. In that way, this technique is cost effective. And it requires short development time when compared with column chromatography. There is wide choice of stationary phase is there, and always stationary phase will be selected based on the nature of analyte to be separated. And it is having more efficiency when compared with paper chromatography. And detection is much easier when compared with paper chromatography. Detection under UV chamber is easy in case of TLC when compared with paper chromatography. Similarly, use of corrosive detecting reagents is possible in case of TLC because these corrosive reagents like concentrated sulfuric acid, spraying reagent will not be causing any damaging effect on the TLC plates unlike paper chromatography. Sensitivity of the TLC is also more when compared with paper chromatography. And in this chromatographic technique, chemically inert stationary phases are used. So vigorous detection methods like application of heat or use of corrosive reagents for the visualization purpose can be used in TLC when compared with paper chromatography. And we can get variable thickness of the TLC plates, which allows for both analytical and preparative TLC. So these are some of the advantages of TLC. Coming to the disadvantage, the length of the separation is limited, unlike the other chromatographic techniques like column chromatography and paper chromatography. The results which are generated from TLC are difficult to produce. Factors like humidity, temperature may affect the outcome of the final chromatogram. Detection limit is high, hence it cannot lower detection limits. Method of preparation also sometimes affect the chromatographic development. For example, in case of spraying or pouring method, getting uniform thickness of the TLC layer is difficult. While in case of dipping method, large quantities of the slurry is needed even for coating the last TLC plate. Applications of TLC. One of the most important application of TLC is identification of compounds. TLC can be employed for the identification of various drugs and natural products like volatile oils or essential oils, waxes, terpenes, glycosides, and so on. For example, for chlorpromazine, a combination of silica gel and a mobile phase combination containing ether, ethyl acetate, and ammonia will be used as stationary and mobile phases. While for the detection, UV absorbance will be recorded for nanometers. So like this, the combination of stationary and mobile phases should be selected and method of visualization or detection should be selected depending on the nature of the sample to be identified. So a list is given in this particular table. The second application is determination of purity of any sample. Direct comparison is done between the sample and the standard or the authentic sample. If the sample contains any impurity, then it shows extra spots on the chromatogram. By this way, presence of impurities can be determined by performing TLC. The third application is examination of reactions. The progression and completion of chemical reactions can be examined by TLC by withdrawing the samples during the progression of the reaction. Isolation and separation. Different compounds will have different affinities for the given combination of stationary and mobile phases. Thus, the mixtures can be separated. So, different types of the mixture of components can be separated by careful selection of stationary and mobile phases. So, a list is given in this particular table. TLC can be used for biochemical analysis. It is widely used for the separation and identification of biochemical metabolites from plasma or blood, urine, and in other biological fluids. It is also having wider applications in food industry. It is used to separate and identify coloring agents, sweetening agents, and preservatives. So these are some of the important applications of the TLC. So we are almost at the end of the video. You can pause the video and quickly try to answer these questions. I hope you have completed these questions. Please subscribe my channel so that you will be notified for my next videos. If you like the video, please mention in comments. Thank you so much for watching.